Good day, everyone. Good day, sir. My name is Lois Irish L. Castillo, and I'm going to present to you the article entitled Monitoring Ground Deformation of Cultural Heritage Sites Using SAR and Geodetic Techniques, the case study of Koirokosha, Cyprus, and is studied by Kyriakos Themistocleus and Basilis Gigas, and the last one is Chris Danesis. So now I'm going to show to you the overview of the presentation, which is I will tackle first the objectives, next is the study area, monitoring geohazards, methodology, results, further research, and conclusion. So now, what is the objective of this article? The first one is to monitor ground deformation at Corocosha using satellite SAR data, GPS, GNSS, and UAV imagery, which is to monitor any ground movement or changes in the structure of Corocosha po. So they use advanced technologies like satellite radar or SAR, GPS, and drone images to do this. These techniques will help them this technique help them gather accurate and continuous data on the site's stability. So the next one is to identify and assess potential geohazards such as landslides and ground settlement that could affect the site stability, which is it involves studying how the site is affected by shifting ground and other geological risks. So by using these techniques like the SAR and also the geodetic monitoring, they aim to identify these hazards early on. This allow them to take action quickly to protect the site and minimize damage to its historical structures and the surroundings environment. So the third one is to enhance conservation strategies by providing accurate real-time data on the structural integrity of the cultural heritage sites. The last one is to develop a low-cost, effective methodology that could be applied to other cultural heritage sites globally. So let's proceed to the study area, which is Kurokosha is a highly important prehistoric site, particularly significant for its well-preserved Neolithic settlement. So in this part, it is provides an overview about the Corocosha. It's also highlighting its archaeological significance, geographical location, historical context, and current state. So it is currently situated in the district of Larnaca, near the southern coast of Cyprus. It is also occupied from the 7th to 5th millennium BC. It also represents a crucial stage in the development of early human communities in the eastern Mediterranean, specifically the Aceramic Neolithic period. It's also initially populated by farmers who migrated from the Near East. So the next one is the monitoring geohazards, which is in SAR imaging, or in this part it emphasizes the importance of integrating various geospatial techniques, including INSAR, GNSS, UAV imagery, and ground-based monitoring for effective assessment and mitigation of geohazards that threaten the preservation of cultural heritage sites. So the first one is the SAR imaging, which is it uses radar satellites to see the Earth's surface. Excuse me po. Even though sa clouds po. So, we have interferometric SAR or INSAR, which compares radar images to detect very subtle ground movements like a few centimeters over time po. And also persistent scatter interferometry or PSI, which is a specialized type of INSAR that focuses on the stable points on the ground, like building of rocks, to precisely measure how they move. So what SAR can do? So the first one is detecting ground movement, which identify areas experiencing slow sinking, rising, or tilting. The next one is monitoring geohazards, which which is it tracks landslides, earthquakes, and other ground-related threats. So in archaeology, it helped locate and study ancient sites. Sorry. So the second one is imagery from unmanned aerial vehicles or UAVs, which is the advantages of this is high resolution imagery, which provide more detailed images than satellite imagery, and efficiency and cost effectiveness, which offer a cost effective and efficient method for documenting sites. The third one is versatility, which can be equipped with various sensors to capture a wide range of data. The last one is the 3D modeling, which enable the creation of accurate 3D models using photogrammetry techniques. So what is the application of this? The first one is monitoring geohazards, which UAVs can help track changes in the site due to factors like landslides, erosion, and earthquakes. Also, the documentation, it provides detailed records of the site's condition for future research and preservation efforts. So, the next one is the geodetic techniques nga, which is essential for local scale monitoring of the Earth's surface, particularly in areas prone to geohazards. These techniques are used to measure absolute positions and displacement at selected locations. It's offering high accuracy at both centimeter to millimeter levels. These methods are particularly used for monitoring cultural heritage and archaeological sites affected by geohazards such as landslides, earthquakes, or ground subsidence. Which and what is the surveying techniques such as total stations leveling and global navigation satellite system or GNSS are employed to measure political positional changes with high precision, which is the first one is the total station. Next is leveling, GNSS or Global Navigation Satellite System. Using these geodetic techniques, a comprehensive network can be established to monitor and document positional changes and deformations in vulnerable cultural heritage sites. GNSS systems in particular offer high accuracy and reliability for tracking even subtle shifts in the landscape, which is crucial for detecting and responding to geohazards. When we have the ground sensors, so in this, the geohazard monitoring uses various sensors like GB-INSAR for ground displacement, FBG sensors for pressure and moisture, capacitive sensors for soil moisture, piezometers for water pressure, accelerometers for movement, crack meters for early displacement, and extensometers, inclinometers, and tiltmeters for measuring shifts in the ground and stability. So the next one is the methodology, which is in local scale monitoring for geohazard assessment and at cultural heritage sites involves integrating various field techniques. So at the Croatia, cultural heritage sites or a combination of INSAR monitoring, field verification with GNSS, and traditional surveying and documentation using UAVs for 3D models and high-resolution images was implemented. So a geodetic network with GNSS receives Trimble RNIs and Leica GS15, and it was established to track ground displacements. So in this methodology, it included multi-criteria analysis to estimate the severity of geohazards and assess the site's vulnerability. So this approach ensures accurate long-term monitoring and supports the preservation of cultural heritage sites with minimal impact. So the results of this study generated high-resolution 3D models, including the DEMs and ortho images of the Croatia site using UAV, imagery, and photogrammetry. So this was supported by a precisely surveyed geodetic network and ground control points established with RTK, GPS, GNSS, so allowing for accurate documentation and monitoring of the site's topography and potential changes in its vertical and horizontal profiles. So this study involves 4 UAV flights over the corrosion site, capturing approximately 450 images and using 60 ground control points for accurate georeferencing in the site's steep terrain. Agiso Photoscan Professional process the data, producing high-resolution orthophotos, 3D models, and digital terrain models. And also, the study generated a high-accuracy 3D model of the corrosion site using UAV images and point clouds, achieving sub-centimeter precision. This model, which was validated against GNSS measurements, allows for detailed analysis of ground deformation and stability changes over time. So, as you can see in Figure 8, it illustrates the seasonal changes in vegetation of at Croatia, which is sparse vegetation observed in October 2016 and November 2017, and denser vegetation in February 2017 and March 2018. To improve the accuracy, vegetation points were masked and removed from the model, and the resulting gaps were filled by interpolating data from surrounding points. So this process created an accurate digital elevation model that represents the ground surface without the influence of vegetation. So during the 13-month monitoring period, DEMS and elevation contour maps were created from point clouds model generating using images taken in February 2017 to November 2017 and March 2018 with a resolution of 5.54 cm per pixel. When compared to GNSS measurements and INSAR data, a slight shift of about 2 cm was observed at the top peak of the hill, particularly at the PILR point, indicating minor deformation at the corrosion sites over time. So they combined GPS or GNSS measurements and PSI analysis to assess ground stability at Croatia. GPS or GNSS data showed a 2 cm vertical change over 5 months, while PSI analysis revealed a 3.3 cm per year average velocity with minor movements. So challenges included a limited number of PS targets. These findings highlights the need for a long-term monitoring to better understand site stability and risk. So for further research, the Cyclops project will advance geohazard monitoring by deploying multi-sensor co-located the systems across Cyprus. So these systems include GNSS reference stations, weather stations, altimeters, and corridor reflectors that improve the accuracy of SAR images. So using TerraSAR X INSAR data with CRs, Cyclops aims to estimate ground deformation with centimeter level precision. This will enable more accurate monitoring of natural hazards like earthquakes and landslides, particularly their impacts on cultural heritage and infrastructure. So contributing to risk management and early warning systems. So the conclusion of this study is to emphasizes the effectiveness of combining INSAR data, satellite positioning, field survey techniques, and UAV-based photogrammetry for monitoring geohazards like ground deformation and cultural heritage sites such as Croatia, Cyprus. So the correlation between geodetic techniques and SAR images indicates the need for long-term monitoring to assess the severity of risk. So this study also highlights the potential of applying this methodology to other sites with future studies under Cyclops and Excelsior projects which aim at developing strategic monitoring, infrastructure, and early warning systems for geohazard mitigation. And that's all po. Thank you.